You know, if you were doing these, if you did this homework quiz and you are adept at using your calculator, and the first 5 are a breeze, right? Because it's just asking you, hey, like, what's the
combination permutation?
Combination permutation. If you still don't have a calculator that can do that, you can still use the equation, right? So let me know if you need the equations. So I don't give, you know, I won't give out a cheat sheet for this because most people have it on the calculator. So
number 130.
You give us a cheat sheet.
Hmm?
You give us a cheat sheet.
I did.
Yeah.
Oh, I did. Oh, I gave you the handout. Yeah.
Yeah.
No, I can't find the handout for today. I had to write. I had to write a new lesson plan. Maybe that's why I'm tired. But the handout was much better.
What time did you get in?
Probably about 3:15. It was raining.
They had a question about how many people are in your microeconomics class.
I think 17.
Because we need to be moved out of that room tomorrow because we're doing a mock trial in the entire 3.
You know what? She was just telling me about the mock trial. She didn't say, hey, you know.
She didn't know you were in the room.
Huh.
So we got to move out of that room. But I had to know how many people.
Let's move to Chili's.
Figure out where you want to do the class. So I'll know tomorrow. If you let me know tonight.
Chili's. Yeah.
I'll prepare tomorrow.
It's at least it's at the most 17. It might be less.
Okay.
Because I think somebody might have dropped. So, but
all right.
It's at the most 17.
So me and Nick will try and figure it out tomorrow.
Okay. All right. The first one's what's the permutation of 6 and 2?
30.
Yes.
All right. Second one,
B.
combination 6 and 2.
15.
Third one, permutation of 5 and 2.
20.
4, combination of 5 and
10.
2.
D.
5, combination of 4 and 4.
1.
1.
Okay.
I will talk to you.
6. C.
Woody, I have something.
I know I got a phone call from you. Sorry.
I got a phone call today too.
It wasn't important. Yours wasn't.
I have a question too.
Yes.
What about my composition class?
We were working on that. Let me go see what
Okay.
you found out.
Alright, thanks.
Are we having classes next quarter?
What?
Because I have no idea what I'm teaching.
You don't?
No,
Well, you're probably on my master schedule that I have so far somewhere.
I'm not. All right.
I said you probably are somewhere. Because I pulled a master schedule and I had to order books, and I know that they're changing days around.
Okay. As long as I'm not on Monday, Thursday, Friday, Saturday, I'm good.
I have no idea.
Are you in a rush?
Oh, you Tuesday.
No, I'm here until like going on.
But you know I do class number.
Like 8:30 night. So catch my break.
Okay.
Sorry about that.
No. It's no problem. I wasn't
We're
there for it, so I wanted to make sure.
We're
That
trying to
you
put
need
in
to
this.
see me.
I'll be there.
You need to see me. Okay.
Thank you.
Yeah.
All right. So before we go on to 6.
Hello.
See what some ghosts knocked down.
Before we go on to 6, does anybody have any trepidation or problems calculating 1 through 5?
No. 6.
Before we go on to 6, anybody have any problems doing the first 5? When it's just it's as simple as that, they're just asking you, they just give you, you know, permutation of this and this. Everybody can do that.
Yes, sir.
Okay, good. All right. Now I'm going to 6. Once we start on 6, this is when you have to decide what it is, all right? So 6 says, in how many ways can you choose 5 cards from a deck of 52 cards?
Order doesn't matter.
So what's the difference between permutation and combination?
Order matters.
Order matters on a permutation. Combination, it doesn't matter. You can't forget the fundamental counting principle, right? If it's not one of those, it's going to be the fundamental counting principle. What's the way, and I says the easiest way to tell that it's not one of those? You have to think. N objects are at a time, right? Because if you have, say, a permutation, you know, you have N and R. So it's N objects are at a time. And normally, if you can't find N objects are at a time, then you're like, well, wait, I'm not sure how many objects, how many at a time, which normally it's just spelled out for you. Then it's probably number of choices, which is the fundamental counting principle. Okay, so in this one, how many objects, how many at a time?
5 objects at 52? No, 52 would be objects and the time would be 5.
5 at a time. 52 objects, 5 at a time. Does order matter?
Nope. No.
So it must be a combination. So you punch in your combination thing, 52 and 5, and what do you get?
C.
C, correct. Okay. Number 7.
C.
Club. 10 members wants to pick president, vice president, and secretary. Each office is to be held by only one person, and no person can hold more than one office. In how many ways can these offices be filled?
C, 720.
Why C? Is it permutation or combination?
It's gonna be a,
That word there?
Permutation.
I concur on the permutation,
Why is it permutation?
because then you actually have the actual, or it gives you.
Somebody has to be a president. Somebody has to be a vice president.
Because the order matters.
Somebody has to be a
Yeah,
secretary.
designated
Order does
order.
matter, so it's a permutation. How many objects?
10.
How many at a time?
3
So it's gonna be a permutation of 10 and 3,
for 720.
and C. Number 8, cars available in 2 types of models in 3 colors. How many ways can you get the car?
6.
Is
Counting,
that a permutation, combination,
counting principle.
or the fundamental counting principle? Fundamental counting principle. Why? Because when you look at it, you say, well, how many objects, how many at a time? How many objects are there?
2
2 objects,
and 3
how many at a time?
3.
Well, no, there's 3 colors. It's not 3. It's not 3 objects at a time because you
One
can't.
car.
You can't have 3 objects at a time because there's only 2 objects. See how that breaks down. You can't say how many objects, how many at a time, right? So it's obviously 2 choices of models times 3 choices of colors. So 2 times 3 is 6.
Trickster.
Okay.
So we would use the.
You'd use the fundamental counting principle.
Can you show, what's the formula for that on our handout?
There really isn't a formula. It's just that you multiply all your choices together. Like we have 2 choices of cars, right? And we have 3 choices of colors. So you multiply them together and you get 6.
Okay.
Like on the next one's gonna be fundamental counting principle too. It's better on the example thing.
But then if you have 4 choices of interior colors,
Then you could do that too.
and then 2 choices of interior material.
Yeah, then you just keep multiplying those. You just keep multiplying those choices because then that's how many different cars you could pick.
Because they're actually choices. They
Yeah.
are not at a time.
Right, yeah, the choices, yeah. So on number 9, it says a test has 10 4-answer multiple choice questions. How many different tests can be turned in to the teacher?
4 to the 10.
Yeah, something like that.
Right, you got 4 choices. How many times? 10, so 4 times 4 times 4 times 4, or 4 to the 10th. Big answer.
B.
B. And number 10, if you're not allowed to repeat characters, in how many ways can you make a 4-letter password from the letters A, B, C, D, E, and F? There's 6 letters. I'm going to make a 4-letter password. And see, if you think about it, how many objects?
6 objects.
Could be 6 objects, could be 4 objects, there's 4 letters, right? 4-letter passwords. So or is it 6 objects,
6
4 at a
objects,
time?
4 at a time, and none can repeat. So that's basically the P. Permutation.
6 objects, 4 at a time, but you're only doing it one time, right? You're only making 1 password.
No, you're not making 1.
But they're
How many
asking
passwords can you make out of that?
How many different possible?
Possible passwords can I make with 4-letter passwords with a number of 6 letters, and the combinations are 360 because you cannot repeat characters.
Right.
All right.
So the repeat is what makes it a permutation.
But also works for the fundamental counting principle.
Right.
Because you have 6 choices, and then you only have 5 choices, then you only have 4 choices, then you only have 3 choices.
But the wording is different in 10 and 8 because it says to repeat, not allowed to repeat characters. That's the only thing that threw me off as to what that is. When I get the same answer, when I do it both ways.
But this is kind of like the one where we were doing the radio station letters, right?
No, because it didn't say couldn't repeat.
Well, it didn't say it couldn't repeat, but it said for the first letter you could only use W or
You can only use 2 choices.
Yeah.
But then the rest it didn't. It didn't have a restriction.
Well, I think the restriction is saying you can only use 6. You can only use 6 choices the first time, 5 choices the second time, 4 choices the third time, 3 choices the fourth time.
So it's
I say it's fundamental counting principle.
4 choices the third time? 4
choices the third time and 3 choices the fourth time. Because you have to make 4 choices. Any questions on this? Besides number 10.
For number 10, can you show us how you would write that out? So we would, is that okay?
I would just write it out.
Please.
Well, David's using permutation, right? So he's using
The 6
6 and 4, right? I'm using fundamental counting principles, so I'm saying, right, let's say here's the thing, I have 6 choices the first time, right, because there's 6 letters, I can't use one of those letters now, so now I have 5 choices, can't use 2 of those letters, now I have 4 choices, and then now I have 3 choices, and I'm just multiplying them together,
6.
Well, how can you have 3 choices?
because there's 6
For
letters.
that last digit, because there's only three letters left.
But you need 4.
Right.
So
You
you
don't
can
need
leave out
one.
6 by
You
4.
only need 1, okay, my first digit, I have 6 letters I can choose from, right? I
Right.
have 6 choices. My second digit, I only have 5 letters now, because I already used 1. My third digit, I only have 4 letters, because I used 2. My fourth digit, I only have 3 letters, because I
Oh,
already
can you
used
make
3.
a single 4-letter password? I got you.
So I got A,
How many
120,
ways
is
can
that
you
correct?
make a 4-letter password?
Yeah.
Oh, sorry,
A, B, C, D.
So it's the same as the batting lineup, where you have 13 choices, but you can only fill 9 places.
But the batting lineup was a permutation.
No, batting lineup was a fundamental counting principle,
It's also a permutation.
No,
but they
bat-
introduced it as the
As a-
counting.
Yeah.
No, the batting lineup was permutation, I thought, because you had like a certain lineup, like lead off.
It is, but
clean
they
up.
also, if you look at what you just said, it's 13 times 12 times 11 times 10 times 9 times 8 times 10 times 6 times 5. So the counting principle applies to the permutation,
Like I said, I'm not-
because it doesn't no, I'm just, right here is what you told us to do,
On the batting lineup?
6543. And then, if
No,
you
you're
just,
right.
and then if you do a permutation on it,
Because I canceled it out on the permutation, right?
You
So
did
it
say-
ended up being the fundamental counting principle.
and a permutation at the same
Yeah,
time.
you can do both of them.
So maybe they're related.
Because they do it both
Just
ways.
because-
Only because, the only reason that is possible is because you're not allowed to repeat characters. If they didn't have that in there, then you would probably do the counting principle on that one.
They're probably like stepbrother and sister that never talk.
Yeah, I don't
one
know enough- I don't
crazy.
know enough about it, so.
Well, it even
Christmas-
says in the margin, it says because all permutation problems are also fundamental counting problems. They can be solved using the formula for permutations or using the fundamental counting principle.
Oh, and it's just easier to use the
It says that
permutation
in this
equation.
that.
It's just easier to use permutation equation, because if you use the fundamental
You just
thing,
plug it
you
in
have
the
to keep
calculator, you're right.
multiplying. Oh, okay, that makes sense.
Darn, I'm good.
I don't know.
I mean, I wasn't positive. but I was
That's
good.
beyond my
Realm.
realm.
Well, you answered it now.
Because they got me teaching econ and stuff like that.
Now you know.
Like I said, I couldn't even find my probability handout, and I was like, oh, now I gotta actually teach this stuff. Because like last week I just gave a handout out.
Did you-
were
did
here,
you-
right?
did you-
were here?
I was here.
See, last week I just gave a handout out, and this week I was like,
Yeah,
what
that's
happened
one
to
I'm
my
trying to-
probability handout? I looked
Okay.
all over that office. I don't know.
Yeah.
Somebody threw them away.
Yeah, right.
I'm like, you know what? I probably gave mine away. Yes. Thank you. Does that mean everybody's ready?
Of course.
Sir?
Yeah.
For this
This thing.
Huh?
I wanna see this.
See what?